Let me know when I'm able to share the screen. See the screen.
Yeah,
Okay.
we can.
Okay, fine. So just first, I'll be covering 2, 3 more points for AWS. So first of all, EMR. So just like we have, checked how EC2 is working, S3 bucket is working. This is EMR. It is one of the important tool. This is mainly used for cloud big data. Okay. So any kind of big data analytics to be performed in AWS, this is the first option that architect can choose. EMR is Elastic Map Reduce. So it will be just working just like map reducing technology to analyze big data. Big data means, if we are having lots of data, millions or billions of records to be processed within some minutes or just like this, then we need to follow this thing, EMR. So it's, very cost. The particular component, it's not a cost effective actually. Uh, it's having high prices or, at the AWS side, and it's totally dependent on the compute power. Okay. So EMR, it's using the clustering technology. We can use in a single EMR, there might be multiple EC2 as well. So some EC2 can be working. For the master node, some should be in core node. So core node will be working. The thing is distributed in nature. I think if you are aware of a big data theoretically, how it's working. So the master will segregate the task between task nodes. All the tasks should be performed by them and they can submit the final thing again to master. Okay, this master node, core node, and task node. And it's working on top of Hadoop. Hadoop is there, and EMR is working on top of Hadoop. So this map reducing thing, it's inheriting from Hadoop itself. And if you are going to install EMR, then Hadoop will be coming automatically in AWS side. So every technology, you can work on top of EMR, just like the same language, Python or Scala scripting. The same thing, the same Python. Some code will be different because actually we need to inherit the library as well. Which particular library or package needs to be used for that Python. So that should be used over here. That is called PySpark. If you are using big data technology on particular EMR Spark technology, it is called PySpark. And so by this technology or by this language, we can quickly design our particular jobs which will be operating as a big data. Which will be able to transaction a big data from source to target and all. And we can able to implement the transformation logic on top of that one. And we can also perform some SQL queries on top of that one. It's with the help of Hive, Hadoop, those kind of stuffs. Okay. So what we just need to do for spinning up purpose over here, we need to choose the VPC, the particular subnet it needs to assign, because if we try to have multiple EC2, one particular EC2 is handling the core. Okay, core node. There is master node, core node, and task node. Master node should be one PC, core node should be 3 or 4 PC we can assign. PC means EC2 server. We can tagged with it. And task node, we can put 10, 12, or 100 of PCs, 100 of EC2s there. But everything should be scaling up. We can by default, if we can open one task node, one core node, and one master node, while our ETL job is running, if we are having lots of data to be handled, then we have the features of scaling up. It should be assigning multiple task node in the same job again. The work will be faster. When everything is completed, our EMR clusters will remove those task nodes from itself, and it will be submitting the result to the master node, and we can get the final answer. So the everything is distributed in manner. And why it is cost effective? Because it's not cost effective actually. We are assigning multiple EC2s at a single point of time, and the compute power is very high. So, if we are, processing any big data and we assign multiple EC2s at a single point of instance, that's why, that time it should be taking much cost, the AWS meter. So that is why the EMR is being used. While spinning up the server, we need to check out the available IPs because we will be launching those many EC2 server. So you have to check also for a particular VPC, we have those available subnet IDs or not. Okay, so those two, three things are very much important. The IP availability, the particular EC2 server, we need to also assign the memory, the RAM as well as the particular hard disk. That last day I told, how we can assign the hard disks, over here. EVS volume, that is actually called, that can be SSD or anything. So that is also important. We need to work with, and this is also, cost. We need to check how much volume. If you choose 4 GB RAM, then how much costing it should be. For core node, obviously, particular memory assignment is much more. I mean, it's extra price than that of task node. Okay, so it's totally dependent on the parameter and which nodes I'm increasing the particular memory size as well as the hard disk size. So we just need to design the thing. Maybe architect can help us, and then we can quickly spin up a particular EMR server, EMR clusters as well. So this is the overall concept. If you can get any opportunity to spin up or anything, or even it's actually EMR is, we cannot get the thing in a free tier account. Okay. So if we have anything in future, maybe we have a console, then we can quickly go through that particular topic. Or maybe in next season, I'll be trying to having some screenshot to understand what actually EMR will be doing. Okay, going to the next slide. Okay, Docker. Docker is, I think you can also want, you have heard about that particular terminology, Docker. Docker, nowadays it's very useful. A particular software or app we can quickly design, but we do not have to think which particular OS it needs to be run. Okay, because Docker is a kind of container. So if we are creating the package, we are creating the package and we are packaging entire app in a particular Docker, then the Docker can be run in any OS. It has that functionality or feasibility to debug that particular app, execute that particular app in any particular OS operating system. And the same thing as the clouds are, helpful that we can scale up the Docker, the container number based on, how much, how we have spinned it up. So based on that, we can scale it up and scale it down. So, Docker, the main feature is this. Let me check. Yeah. The storage of, okay, what we have done in, I have a wish to show you how the Docker should work, and we can package a MySQL. We have already gone through the MySQL part. Let me check, maybe tomorrow or maybe next season, I'll be having some hands-on on the particular Docker topic. So Docker is having a hub or repository where we have the images for various tools. Just like if you are running a Java code in a EC2 server, okay, then the Java code can be packaged in a Docker inside an EC2 server in AWS, and it can be run easily from there. So Docker is just like a package, and it makes useful to run a particular app in any particular OS. So you do not have to think whether it should be running in Linux or it should be feasible to run in Windows or any Mac, just like this. Okay. And there is Amazon ECR as well, the same thing, electric container registry. So it should be also using for the same purpose. This particular link for docker.com, it's a hub or repository. We can say it's available for publicly. The Docker, you can say it should be accessible by that particular region or that particular account for everyone. But it's for private basically. Particular Amazon account can be, whoever has this account access, they only can use that thing. Okay. So now next topic is serverless computing in AWS side. So nowadays we can hard that lots of things are serverless. That features are provided by AWS side. Not only AWS, every cloud provides that particular thing. I'm just going ahead with AWS. So the first This kind of things are AWS Lambda function. So why it's serverless? Because actually, when I'm running the Python code and everything, you can see I have installed Python in my system, this server, this particular server. But I have also installed MySQL database in that particular server. At the beginning time, I give you the installation guide there, and I have installed everything over here. The same thing I can install this Python if I do not have any machine. Maybe in a particular project I have to work Python, but the Python needs to be installed in a particular EC2 server. Okay, so I can install that Python in EC2 server and work the Python accordingly. I can install the PyCharm there, and I worked over there by I mean on top of Python or any other language. Maybe I have installed MySQL server over there as well in a separate EC2 server. So for that, what thing is chargeable? The EC2 server launching thing. We have to launch a EC2 server. We need to tag a EBS volume. EBS volume is the hard disk. So and after that, when everything is fine, then we can install those software and we can work on top of that. Okay, but nowadays there is serverless concept. So if we just want to run or debug Python code, maybe the Python code is bigger one or small one, that doesn't affect. So we can we can use Lambda function. AWS Lambda is there. It's a tool in AWS. A component is there for AWS where we have to choose which language, programming language we will be using that particular Lambda, and maybe JavaScript or maybe Java, maybe Python, anything, maybe Ruby. So I have to choose the thing, and there is a console and we can directly type the code and execute it. So we do not need any server over there. And the pricing purpose, we just have to pay the computing thing. How much time the code should be taking for execution. So that time maybe in microsecond or just like this. So the pricing thing is also based on microsecond or second. So how much second it has been executed. So that there is $0.002 per second or per microsecond. This is the pricing calculator. It's very less. And how much time it's been executed, that will be taking time. Based on that, the pricing calculator will uh, I mean uh, calculate how much dollar we need to pay for that particular code to run. Okay, it's not only for language running. Nowadays we are using database messaging services as well. We can message or mailing service by AWS component, the storaging activities just like S3 bucket. If we are aware of we have already covered the S3. If you can remember, for S3 we do not have to launch any server, any EC2 server or any other server. We no need to launch for S3 bucket. So it's also serverless. But actually, if you just have, in the backend, there must be a server. But from the user perspective, who is using the AWS, they do not have to pay or they do not have to configure for the server. That's the concept. That is why it's called serverless. But obviously, there maybe a server. Otherwise, you cannot install Python over there. But in front of customers, as we cannot see the server, we can only see that particular thing in front of us, and we can quickly work on that one. Okay, so that is why it's called serverless. We are not opening the server. We are not installing the antivirus. We are not installing the patching update or anything, any registry configuration. Nothing we have to do for the server. But if you are maintaining a server, you have to do this thing daily basis. If you had your own PC, you need to check whether your PC is virus free or not. The OS is activated or not. OS is updated daily basis or not. So this kind of stuff we need to check. Even the same is for EC2 as well. For EC2, you need to check everything is fine. If any patch needs to be installed, you need to install this thing manually as well. Or maybe a software patch. Maybe SQL Server. You have installed SQL Server there or MySQL over there, but suddenly after 3-4 years you are checking while integrating that MySQL software, the old version of MySQL software is not integrating with our analytics tool. There is a different analytics tool. The analytics tool is saying that they need the updated softwares or patch the software so that it should be software compatible. The integration should be fine. because of the security purpose. So that time you need to install the patching activity. I mean, you need to install the upgraded MySQL over there again in the server. So you are maintaining that application. So that is why I mean the serverless is playing the key role. I mean, maybe we are paying a bit higher, but I mean sometimes we are paying a bit higher. If you are using a database, we are paying a bit higher. But if you are using AWS Lambda to run Python code, it's not paying too much. Now, if I just come for a RDS database, I mean, you can install a MySQL in a EC2 server. You are managing the server as well as you are managing the software. And there is also ready-made database available there at the AWS site that is called RDS. RDS maybe it should be in Postgres, it should be MySQL as well. So it's already ready-made. No, I mean, you do not have to afraid of whether the patching activity is done for the databases or not. So the database can be managed by RDS by themselves. I mean, AWS side. So this is also we can call the cloud. The serverless over here. As we are not taking control the server, we are only controlling the database. They are giving us the host name. We can create the credentials from the AWS console, and we can quickly connect particular database from anywhere to the same network. So this is kind of concept of serverless. We are using only application. No need to worry about what the server is going to do. Okay. So till now, any doubt what we have just covered up? Okay. Hopefully no.
We use step
Yes.
function in Lambda. May I know what is that?
Yeah. Step function. It's also same kind of. I mean, AWS Lambda. It's also some. I mean, we can tell. It's a serverless operation as well. In the details, that is not been covered in these courses. Maybe in next week onwards, when we'll be covering the AWS, can cover the step function as well. So it's been used for ETL purpose. Okay. So we can also collaborating Lambda as well as step AWS step function to cover up a particular ETL. From transforming the data from source to target, load the data as well. So we can basically it can be used as a ETL from AWS side with the serverless feature, can say. But the detailing thing we can, if you want, then we can quickly cover up in the next session the step function. Okay.
Yeah,
Okay.
okay.
Going to the next slide. I'm just trying to get a particular console access from Lohit or the admin team, anyone from AWS side. If we have that one, then we can quickly go through or quickly hands-on a quick code to be run on top of AWS Lambda. Can quickly check the messaging services, or just like step function as well. With small codes and all how it's working. So just trying to check in the next season. The next when the same time kind of course will be started in the next season. Okay. So now I'm covering going to start Git. I think Git we are all about. We have heard that word Git. So Git is mainly used for version control system. So each of our project, if we are a developer, um, then if you're not even a developer, if you're working in a support team as well, so you can see if we are designing a code or developing a code in the development environment, so the code can be pushed a particular repository. Your code can be archived or stored in a particular repository. So repository means a storage space, we can say, and that is called. That is the main function of the Git. We can take the thing. We can store the thing over there. But this is not only the function; it's control the version as well. So if any modification or anything is required, then we can modify on top of that. Okay. And suppose we have multiple developers in a single team, or they are working at a single code base over there. So each of them needs to change a particular module, and they need to merge the same thing again, finally to this particular code base. So if they are working differently, then they are working in, parallelly they are working in a single code base but in separate module. And when their work is done, they do not have to collect each one's task, and they can append their design over there. Instead of doing that, they can commit their changes in the code base, and Git will do the rest of the stuffs. Git has that functionality that it can merge everyone's changes in a single go. So that is the helpful of Git. It's control the version as well. For a particular day or particular past of a past day, if we are just committing anything, in code base we are changing anything, that particular thing can be fetched as well. So suppose we designed something, customer told it is fine. After a few days, customer second told, this is not fine, just go to the earlier version. Then you have the capability to go ahead with the old one. You can check from the old commits what is the change, and that particular thing you can roll back again and work on that one. So Git will contain it will maintain the version control as well. Which version you have just commit, then it can check it. Also, suppose one developer has worked particular thing and he resigned from the company. But if the thing is being stored over there, the new developer can check the thing, and he can understand in which version what change is there. Before changing the thing, before committing the thing, you need to put some comment there. What type of changes you have done, and what is the feature, what is the rally story or Jira story. Based on that, you have changed that particular thing. Those kind of comments is very much important. You need to put over there while committing a particular part. So a new developer can quickly check and understand within 1 or 2 days what is the changes and what based on what or which code base the work is going on. So that is why Git plays an important role. And in each of the project, if you are developing a thing, then Git is a mandatory part. It's not only Git actually. Code base repository or version control thing is a mandatory one. Maybe a particular application is not using Git, it's using a different thing, different code base repository, different version control system. That is possible. But Git, we can see it's most popular one in the market in the application. Okay, it's so free and open source, and it's distributed in nature. So what is the particular, what are the features of Git? I already mentioned that track the changes across multiple files. Okay, you can track the changes. Time travel into old version. So that I already covered, that you can time travel. If there is any wrong, then we can quickly go to the past version and we can check what are the things, and we can bring this back again into recent version. Okay, rollback we can do. Collaborate and share changes, that is possible. Combine changes, we are pushing the changes and merging the thing. And compare the version, that is also possible. You can compare between versions in a single window by using of Git. So those are the features for Git. And there is a difference for Git and GitHub actually. Some of the project you can directly use GitHub. But even I was also, when I studied it first, I was also confused. I thought Git and GitHub is same. It's almost same, but the main difference is Git is a software. It's the main software, and GitHub it's a service on top of that software only. Okay, so GitHub generally we can use in a graphical or portal kind of thing. We have a GitHub portal. Someone you can use GitLab as well. GitLab is also a service. It is not a software. So I have the next topic, just like, yeah, GitHub competes with the last point. You can say GitHub competes with GitLab, Gitbucket, AWS Code Commit, and Git competes with those are the other things, just like Git, CVS, Azure DevOps Server, Subversion. So those are the things. But the main concept, main software is Git, and we can directly work on Git by terminal. We can put Git bash, command the Git bash to commit any changes or to create any new repository. So to create pull request or anything by Git bash and all. Okay. So let me just go through some some basic concept of Git by today and how to install the Git. There is a particular link that gitscm.com. So there we can install Git for Windows or Mac or Linux if based on which particular thing we will be working. If we install the thing Git bash, that particular software will be installed in your system. Okay. So it should be just like looking like this. If you open that thing, that should be working as a terminal. You can put command over there and it should be working as its own way. You can install the thing in the software. The link is gitscm.com. Okay. Let me quickly check. Yeah, it's there. And this is the latest for Windows. You can check if you have Mac or any other thing, you can install that thing. And there is graphical user interface as well for Git. Okay, so you can install that thing as well, Windows GUI. So you can install that thing if you are, you are not good at the terminal code and all. It's same like if you are working in Linux server by PuTTY. So the same thing, present directory, change directory. If you just want to go to root directory, so this kind of code, it's very much helpful over here. Then you can you should have the knowledge for making directory just like mkdir, removing files, rm. So this kind of basic stuff just you need to know before working with the terminal. If that is fine, then you can quickly go ahead with the git command. Git command is very simple. You can also find in web as well to work in the bash, git bash. Okay, going to the slide again. So you can install that stuff. Currently, it's not in my machine. If we have in the next session, I'll be also planning for Git to be quickly hands-on on top of that. So we have this kind of graphical interface as well. So graphical interface should be working, based on clicks and everything. There are options for pulling request. You just have to click on pull. You can stash the change. You can push your change over there. So those kind of GitHub desktop, source tree, tower. So those are the important GUI. So based on your particular project you will be working, you can, they can guide you which kind of software is compatible with your project, and they can tell you to install with that one only. If they're using Git command, Git GUI. Otherwise, Git bash, that Git as a terminal command is the most popular one. And if they're not using any GUI, then you have to only use the particular terminal portal only, terminal window. So this is a particular screenshot I just put from source tree. It's one of the GUI, how it's look like, how the branching thing, why we are branching the thing. The branching concept I'll be covering tomorrow. This is a GUI. Just I want to say, each of the line you can see the description of particular work, and this is the commit point. Okay, there is a separate branch they are working. If the working is completed, they can come, they can merge the branch to this branch, the main branch over here. So this kind of graphical interface is very much helpful to check the commit points when the codes are being committed, and what are the separate branches when that particular branch should be pushed to the main branch, and the main branch should be go to the production live. That code should be the live one. And suppose any wrong thing happens into that particular save point or commit point, then we can go to the previous one. That is called a version controlling. We can check each of the version when it has been committed, which purpose it was been committed, and if we just want to go to the previous version, then how to check it. Just like over here, you can see 15. Suppose this is stored. Git should be stored. The code base should be stored in web. But you can also clone the same thing at your own system, because you will be owning in your local. You can work in your local desktop or local work machine. Then, you need to clone that particular repository in your local if you want to change anything at your local, that can be modified, and it will compare from the web portal that there are 15 changes needs to be committed. It's not been covered, so it can show you this kind of stuff. Then you can pull those changes at your local, that can be updated. Now you can modify everything at your side and push the change. Then it should be pushed into portal. Then you need to commit everything. This is the whole concept actually. I mean, everyone can see what changes you have made, and it's the visibility is for everyone. Even anyone is doing any wrong code or any bug at the code, then it can be easily detected who has marked that particular stuffs and what are the fault. Then I mean, the manager can easily see who has done the thing and all. But I mean, it's not for actually that purpose. It's just for versioning thing. If we are wrong with any version, then we can go ahead with the next, I mean, the correct version, or we can pull the old versions as this kind of stuff we can quickly do. So Git repository is the main repository that we are storing the code base. Git repo is a workspace which tracks and manages files within a folder. Okay, for a new project, suppose we are working in a new project, then we can ask for, I mean, we can create that particular repository. So let me just go have some comments over there. Maybe if you are working in a big project, some projects we do not have to go ahead with the Git repository creation. There is separate team for Git repository creation. They will create the repository for us. We can raise write access for the repository so that we can write codes or code bases on top of that repository. But if it is a small particular project or just like this, then we can work on top of the repository as well. The company will give us the repository permission or access for creation of the repository. Generally, as per my experience, there is a separate team for Git repository. They can create the repository for us. They can give us the permission. We have to raise the ticket. If we have everything, then we can create the branches based on the developer's choice. I mean, which particular branches we need to create and all. That thing we can do from our side. And after changing, I mean, after going ahead with the code bases or everything has been completed, then we can merge the branches in the main branch. So this is the main concept actually. We, and data engineer perspective or any developer perspective, we can go ahead. In data perspective, what the particular codes? The SQL codes. The SQL codes means that we covered earlier. Maybe not that easy. It should be complex one. It should be complex one in nature. We are creating the data modeling itself by the SQL commands and all. We can create large views, the table structure, the DDLs, DMLs, any other scripting logic. We are using some PL SQL code blocks and all. Particular SQL, I mean, store procedures as well. So those kind of stuffs, big code bases, we can easily store in Git repository. The data engineer perspective. Okay, if we are using code bash only, we are not using graphical user interface, then those kind of commands we can use git status in the git bash. If we just put this command and enter, then it should be providing us the information, the present status of that particular repository. Okay, so just like if one commit is there, I mean, how many commits, if anything needs to be merged or any this kind of stuffs, it will be showing at the git status. The same window at git bash. Git init, this is a particular command for creating a new repository. Okay. Okay. Now I already told what is commit. Commit means we made some changes in the code base, and then we want to change the same thing in the branches. Okay. Then we need to commit it. So specifically what we can do, multiple things we have worked for today. The entire, I mean, I have changed multiple files in the code base. Okay. Then in a single commit at the end, we can push the changes in the main code. This is the concept. But before commit, this is an important picture. Before commit, this is the working directory. We need to add the changes, particular changes in the staging area. So that can be done by git add command. Okay. So we cannot directly commit. So there is an intermediate thing that is called staging area. So you have to push all the changes into staging, that is staging the change by git add command. Then there may be multiple changes can be stored in a staging area. Then in a single commit, git commit, we can push everything into the repository, the main branches. Okay. The branching concept and everything, the rest of the part for the git quickly covered by tomorrow, as we have 2 sessions been allocated for git. And the pooling, pushing stuff, stashing the thing, maybe how we can use at the git repository or git, we can create the git branches. What are the stuffs? Maybe a more thing on the git GUI perspective. What is the thing? These particular things we can quickly cover up tomorrow. But git is very much simple. Actually, all of the projects they are using the thing, and even if you are near to the project, even sometimes if you have some knowledge, that is fine. If you do not have git knowledge, it's, I mean, you can quickly understand what git is. And tomorrow I'll be also trying to show something about how to connect PyCharm with git. Maybe you are working in a tool, I mean, you are working in PyCharm, you are directly taking it from cloning a repository from GitHub or GitLab, anything. Then you can directly push the thing from the PyCharm to that cloud. I mean, Git. This kind of quick example we can show you tomorrow. So those are the basic things I have covered. Yeah. So tomorrow we'll be covering the rest of the part for Git, and maybe not by this session. Next session, if there is anything, any more thing is pending, then you can quickly consult tomorrow. Then we can have a quick planning from my side as well. Then I'll be covering those things maybe next session, which will be starting from next week or maybe next month. I mean January onwards. Okay, just like step function that someone told. So this kind of stuff shall be trying to cover next session with some quick hands-on exercises in AWS console. But first of all, I need the console access. I'll be trying to get from Lohit or any other as soon as possible. Okay. Okay, till now, any doubt what we have learned today? Okay, hopefully no. Let's connect tomorrow as the last session for this particular course. And if there is any more thing you need to discuss or anything, if I have the capability tomorrow to cover up, then theoretically, then it's fine. Otherwise, I'll be trying to add those kind of topics and the next, I mean, this kind of courses again with a quick hands-on on that topic, so that that can be easily understandable, or you can have a quick guidance on that one to go ahead with that stuff. Okay. Okay. So that's all for today's session.
Thank you, Saptik.
Yeah. Thanks. Thanks, everyone.
Thank you,
Thank
Satya.
you. Bye.
Yeah. Thanks, everyone. Bye bye.